We're going to talk about sorting images. We're going to talk about sorting images using machine learning. Most people have a smartphone and they take a lot of photos using their camera, but it's not just taking photos with a camera. You may save images from from the web. People may send you photos, and these all accumulate in your phone, and they can be in the thousands to the point that this happens. And in my case, this has been going on for the 13 years that I've owned a smartphone. And you have to offload them at some point unless you have infinite money to subscribe to iCloud or whatever service stores your photos. And so you get all these JPEG files on your computer, and this goes on and on for years and years. Every time I run out of space, I have the 50 gigabyte plan, in case you care, and it just becomes you can get gigabytes and gigabytes, even terabytes worth of digital assets on your computer, and keeping them all organized is pretty much impossible. What would be great is if I could just separate out the photos of mine, the precious photos, from all the other photos, not necessarily junk, but photos that are from the web or wherever they. If you lose them, photos that I can back up. So if I lose them, in theory, I can get them again from the web. Whereas if I lose my own photos, they're gone forever. So I just want to make sure that all my photos are in one place and all the other images are not in the same place. So what I want to do is separate the treasure from the archive or junk or whatever word you want to use here. And we need to automate this somehow because it's just an ongoing effort that is, trust me when I tell you, it's unsustainable. You can't do this forever, certainly not at today's volume at which we take photos. Now, when you take a photo, you may or may not know that there is a lot of information that gets stored in the photo. So look down here where we've circled in orange. It tells you the date you took the photo. It tells you the camera. It tells you the format. It tells you the resolution, the size, and lots of other things like focal point and ISO, image shooting speed, etc., etc. So we could sort our photos this way, but there's a problem. A lot of photos uh, or a lot of images do not have this information, or they only have partial information. And there's various reasons for this. When you share a photo on WhatsApp, uh, the camera gets the photo date, the location, and the camera may get removed. And if you're not sure about this, here is a diff of the EXIF data in different types of images. So the one on the left is from a photo that I captured. The one on the right is from something I downloaded from the internet, and it has the internet photo has some information, but not a lot. It has the size, it has the resolution, it has the the mime type. So it has a little bit of information, but not a lot. And that means I cannot sort by camera, for example. If I could sort by camera, that would eliminate everything that's not taken by photos that I've owned. But not, yeah, we said not all of the data is erased. So can we recover the more interesting information, like what camera was probably used to take that photo, from what data is there? In other words, using the machine learning terminology, can we determine y, where y is the camera, from the input variables such as the image width, image height, image size? And so to keep it simple, I've gone for the image height and width, and that is in our data down here. That you can see, it might be a bit small to read, but it is there because the data has a certain height and width in any image that you download. So For the photos where I do have this information, whether it's my photos or photos from the web that do have it, we have training data on the left. And then on the right is test data where we want to fill in at least some of the blanks. So with a little demo, firstly, let me show you. Here's basically the code that I wrote. It's not very much. And we have two CSV files. We have photos with the training data, i.e. all the EXIF fields that we're interested in. And we have the test data. And we want to create a classifier from the training data that's from the training CSV, and we want to produce a model so that we can feed in the test data and predict what the camera was that was to create it. And I'll just quickly show you that running. And this outputs a lot of data, and it's filled in blanks where we previously had. Now let me show you this within. I saved the results of this earlier, so we don't have to look at it that way. If I can find my presentation again. So on the left was the test data that did not have the camera, so hence this blank column, but did have the image resolutions, which we could use from the MLP classifier, which is a type of neural network. And from that data, we were able to guess whether what the camera was that was taken. And I've never owned a Nikon camera in my life, so I know that anything that is Nikon is not a photo taken by me. If it's with Apple, it probably is something I've taken, but let's see. Let's see if these results are correct. So with the Nikon camera, I was finding results like these. And you can see that this is a photo that I saved from Reddit. Whoever took this photo, who's a cat lover like myself, used a Nikon camera. I saved another photo. I think it was, this must have been a thumbnail from a video for a soccer website. And I was not at this game, so I know this photo is not taken by me. And you can even see the resolution here is different to what I would expect from a photo taken by myself. For an Apple camera, i.e. an iPhone, I got results like these. And this was a photo that or in fact, one of my relatives who also has a phone took. And this is a precious photo. This is something that is not going to exist out there on the web, and so I probably want to back this photo up. So this through this MLP classifier, I can figure out the camera, and I can separate the precious photos from just photos I need to archive somewhere, and would have a different backup strategy for on my computer without paying excessive charges. So there you have it, but that's not the full story. According to my test data results, this is also taken by an iPhone. Now, I probably you don't need to be an expert to figure out that this probably was not taken by an iPhone. Now, it may be a photo of an old print that was taken by a camera, but we don't know that for sure, and so neural networks can't tell us everything. So just knowing the resolution does will not be foolproof, but it's a first step to sift through your masses of digital assets. We only use resolution to decide. So, in conclusion, neural networks. The actual code you saw is very simple. There is it is a bit of preparation to find the data you want, but even more than that, the biggest thing that you need to know if you're going to use this approach is you need to know your data. Does the resolution necessarily tell you that it was what the camera is? It may, or the photo may be resized but retain the camera information. It may be that it's a photo of a photo, and so it's not really taken by that camera. You might want to rely on focal length in that case. You might want to look at the color saturation, which is another field within the EXIF metadata. But the bottom line is you need to know your data. That's all I have to say. Thank you very much.